Hello, welcome to Lesson 19, Algebra, Negative Numbers. So today we will be working with negative numbers. So first, let's find the change in temperature in Celsius. And they give us this little key here, where 1 degree Fahrenheit is equal to 33.8 degrees Celsius. And for here, we really want to understand the concept of negatives, so we're not going to do all the calculations. So get out a calculator. It's okay. It's not cheating for this because really we're trying to test the concept of the negative right here. So let's get right into it. Negative 10 Fahrenheit to 20 degrees Fahrenheit. So what is that change in temperature? What is that difference between them? It's not 10 because this isn't just positive 10 to positive 20. It's from negative 10 to 20. So that means you're going to have negative 10 and it's going to be negative 9, negative 9, negative 8, negative 7, blah, 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 right? All the way until 20, which means there's 10 more here until you reach 0, right? That's 10. And then 0 to 20 is another 20. So the distance really is 30, right? So with that in mind, the change in temperature is 30 degrees Fahrenheit, but we're not done here. You have to do 30 times 33.8. Why? Because we're using this conversion factor here. So let's plug that into the calculator. And we get an answer of 1014 degrees Celsius. All right, let's just do one more problem to warm us up here. And let's do the negative one. So let's do 4. So negative 5 to negative 20, right? Or sorry, 20, positive 20. Again, you have to go 5 points to the right to get to 0. And then 0 to 20 is another 20. So here, the distance is really 25. So again, let's use our calculator. 25 times that 33.8 to see how many degrees Celsius we're at. 25 times 33.8. And that is 845 degrees Celsius. All right. Draw a number line and graph each number and its opposite. So now, if you aren't familiar, a number line is going to be this line with lots of dashes in the middle, representing different places of the numbers. Sorry, it's not going to be perfect. I'm trying my best to make each line even here. This is roughly, right? So here, really we only need this number and its opposite. And what do we mean by opposite? It means the other sign, which is positive 6. So we really just need these two. And what's important is it doesn't really matter where you put that first number. Let's just start negative 6 like right here. But what's important is how far it is from 6. Like where does 6 need to belong here? And we know that negative 6 to its opposite is going to be itself, or it's going to be adding itself twice, right? Because negative 6 plus 6 is 0, right? And then to get to its opposite, you have to add another 6. So we're going to count 12 places, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is where positive 6 will be. Let's try one more. Let's try number 10. Let's try 5. So here, I'm not going to make it too big because it doesn't need to be too big. Or actually, it needs to be a certain, it needs to be big enough, right, to fit in all those jumps. So here, if this is 5, we can go back. We can count 10 spaces, right? Because to get to negative 5, we would need to first move back 5 until we reach 0, and then go 5 more back. So 1, 2, 3, 4, 5. So that's 0, and negative 1, negative 2, negative 3, negative 4, negative 5. So that is where it belongs, and this will be right here. All right, for this one, let's just try to go over everything here because this is a valuable lesson. Draw a number line and graph 3 whole numbers that make the inequality true. Inequality means greater than, less than, or equal to, right? Your alligators, if you remember that way, the alligator eats the bigger thing, right? So here, Q, right, our variable, is greater than 6. So 3 whole numbers that are greater than 6 must be plotted. So I'm just going to start with 6, just somewhere, right, in a decent spot. Anything greater than 6, anything to the right of 6 will be greater, right? Because this is 7, 8, 9, 10, blah, blah, blah. So here, right here, here, and here. Just because why not? So this is 1, 2, 3. 3 more from 6. Actually, so let me count like this. This is 6, 7, 8, 9, 10, and 11. So these are your 3 whole numbers because they're greater than 6. So I'm going to move through these fast, right? Because we get the point. So here, 10 is these, or b, the variable minus 6 has to be greater than 10. I'm going to just set 10 as this n because why not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means here, b has to be at least 11. Why? Because if it was, b has to be at least 17. Because if it was 16, that doesn't make sense, right? Because 10 is not greater, right? So it has to be at least 11. So this means it's going to be really anything past 10 here, right? The way I drew it. Now, if 10 was over here, that would be different, right? It can't be any of these. It would have to be, 12, 13, or 14. All right. Actually, I take it back. There's a lot, and these do take a while to solve. But let's just try one more kind of interesting one, complicated one. Let's try 17. So here, we have 8 is less than p plus 4. Another way you can think about it is p plus 4 is greater than 8, right? So that means whatever p added 4 will be greater than 8. So I'm just going to say 8 is here. And actually, no, I take it back. Let's put that 8 more to the right, and you'll see why I do that. I'm not going to write out every single number. Just, you can keep it in your head, right? So if you have 8 here, let's say p is 5, right? So 8, 7, 6, 5. You might think, hey, that's less than 8, right? So that can't be the case. Actually, no, because this number is p. And p plus 4 gives you 9. So that actually does work. So here, these numbers have to be, or can be, I should say, less than 8. They just can't be 4 or less. Okay, so here, 6 would work, 7 would work, and 6 would work as well. But 9 would work, 10 would work, and anything past 8 will work as well.